Okay, here we go. We're going to finish up the lab for those of you that are having a little difficulty getting done. Here is the data that you might need just in case if you missed any of this on the board, so feel free to pause and write down whatever it is that you might want to have. And now moving on to the calculations. So just a reminder, we did some of this in class. So number one, I'm really not going to go over again. You should already have, I'm just going to go through the basics, subtracted off the water vapor pressure, converted the grams of magnesium to moles, and then used the mole to mole ratio from the balanced equation to get the moles of the hydrogen. And then using the subtracted pressure, the temperature, and the moles of hydrogen, calculated the volume of hydrogen that should have been made. Again, that's our theoretical yield. Question number two, we didn't really have time to talk about. I'm just going to briefly go into that here. There really are about 3 different ways of solving this problem. What you want to do is to take your answer to number 1 and correct it to STP. So if you think about what that means, again, STP, standard temperature and pressure. You should all know what that means. If not, look it up in your notes or look it up on your reference packet. Remember, all those gas law formulas are right on the front. So you have your volume, theoretically, that should have been made that you calculated in number 1. Well, that is at a certain pressure and a certain temperature. I want to know what that volume would be at standard temperature and pressure. So if you think about what I just said, there's one formula there that would work easily. You can also think about, well, it would be the same. I have the number of moles. I can figure out from moles with standard temperature and pressure. Again, think about what formula would fit for that. And then there's at least one other one that will work, and if you come up with that one, kudos to you. All right, we're going to move on to calculation number 3. This is the one that we were working on when class was ending, and some of you may not have completely finished this one. To calculate your percent error, your calculated volume from analysis question number 1 is the accepted value. So again, I'm pointing that out down here. The formula for error, percent error, is take your experimental value. So this is going to come from your volume from the data table. So look back at the data table. What was your volume? Now you do need to pay attention here. Our calculated answer from number 1 is in liters. Your volume from the lab was in milliliters, so you're going to need to convert. I would recommend just go to liters. So change your volume to liters and put that in there. Again, this is the one that came out of your data table. That's the experimental value. The answer that you calculated in number 1 is the accepted value. Now pay attention, there are parentheses. You have to make sure that you do that subtraction first and then divide again by the accepted value, which is the volume from number 1. Because it's a percentage, you want to multiply by 100, and that will be your percent error. Anything under 10% is great. That's what I expect that you would have. And really for this lab with the measurements done via the electronic balance should be pretty easy to do unless you had a really bad time with your udiometer. And I didn't really see any major issues there. Now, you do need to compare data with 2 other groups. I want you to make a small table like the one that you see here that goes in your lab report. And again, since we are not taking class time to do this, that's where that wall is going to come in. So yesterday on Edmodo, I uploaded a link to the wall, and so you need to follow that link from Edmodo post yesterday and post your data up there. Only one partner from each lab group needs to do that. Now, question number 4 also needs to be answered, questions about error. So be thorough, come up with several different possibilities that error could have occurred, whether it occurred for you or not. Come up with some possibilities. Question number 5, the last one, says use the unbalanced, so in other words, I'm giving you a hint, please balance that equation below to find what mass of sodium azide, that's the substance right here, the NaN3, is needed to inflate an airbag to 70 liters at STP. So this is the reaction that causes your airbag to inflate. So please take a look at that and calculate. So you are trying to find grams of this. You've got the volume of the nitrogen gas. That's what causes the airbag to inflate. So we've got the volume, and we know it's at standard temperature and pressure. So you've got enough here to find some piece of information. I'll let you think about that and convert your way back over to grams of sodium azide. Now, I put an X through the conclusion, hence we aren't going to do a conclusion for this particular lab. We'll call that good for this one. So again, lab is due on Monday. Make sure you get your data posted, get your calculations finished. Have a great day. You can work on this in class after you have worked your way through at least one of the reviews and practiced every type of problem. Have a great day and a great weekend. See you on Monday. Please study.